The paper, SpotDiffusion, a fast approach for seamless panorama generation over time, proposes a novel method to overcome the limitations of existing approaches. Let's start with the core problem. What are the challenges associated with generating high-resolution panoramas using diffusion models?
Diffusion models are powerful for image generation, but they typically train on fixed-size images. Scaling them up to generate panoramas, which are much wider than standard image resolutions, presents several challenges. One issue is computational efficiency. Existing methods like multi-diffusion and sync diffusion rely on generating and averaging multiple overlapping denoising predictions, which can be computationally expensive. Another challenge is maintaining perceptual coherence, ensuring that the generated panorama is seamless and free from artifacts.
So the paper proposes SpotDiffusion as a solution. Can you explain the key idea behind this approach?
SpotDiffusion addresses the limitations of previous methods by eliminating the need for overlapping denoising predictions. Instead of generating multiple overlapping windows and averaging them, SpotDiffusion uses non-overlapping windows that shift over time. This means that the denoising process is applied uniformly across the entire image, ensuring seamless transitions.
That's an interesting approach. How does the shifting window mechanism work in practice?
At each time step, SpotDiffusion randomly shifts the non-overlapping windows across the panorama. This ensures that any seams or artifacts that might arise in one time step are corrected in subsequent time steps. The random shifts effectively distribute the denoising process across the entire image, leading to a coherent and seamless final output.
So the key is to ensure that the denoising process is applied uniformly over time, even without overlapping windows. Can you elaborate on the benefits of this approach?
The main benefit is computational efficiency. By eliminating the need for overlapping windows, SpotDiffusion significantly reduces the number of denoising predictions required, leading to faster inference times. This is a significant advantage, especially for generating high-resolution panoramas, which can be computationally demanding.
It sounds like SpotDiffusion offers a good balance between efficiency and quality. How does it compare to existing methods in terms of image quality?
SpotDiffusion produces comparable or even better image quality than existing methods, such as multi-diffusion and sync diffusion. Qualitative and quantitative evaluations demonstrate that SpotDiffusion generates coherent and sharp panoramas without noticeable border artifacts.
That's impressive. Can you provide some specific examples of how SpotDiffusion performs in comparison to other methods?
The paper compares SpotDiffusion to multi-diffusion with varying stride sizes. Multi-diffusion requires large overlaps between denoising windows to produce seamless panoramas, which significantly increases the computational cost. SpotDiffusion, on the other hand, achieves seamless panoramas without overlapping windows, resulting in a 6x speedup in inference time.
So SpotDiffusion is significantly faster while maintaining or even improving image quality. What about its performance in comparison to sync diffusion?
The paper also demonstrates that SpotDiffusion can be used as a drop-in replacement for the inner multi-diffusion loop in sync diffusion. This leads to a 3x speedup in inference time without noticeable degradation in image quality. The generated panorama images are coherent and sharp, highlighting the effectiveness of SpotDiffusion's shifted window denoising approach.
It seems like SpotDiffusion is a versatile method that can be integrated into existing diffusion models. Are there any limitations or potential areas for improvement?
While SpotDiffusion offers significant advantages in terms of efficiency and quality, it does not guarantee the same level of image quality as dense multi-diffusion with a very small stride. The paper suggests that future work could explore dynamically adjusting stride sizes during the denoising process to potentially combine the benefits of both methods.
That's an interesting direction for future research. Can you summarize the key contributions of SpotDiffusion?
SpotDiffusion introduces a fast and efficient method for generating coherent and sharp panorama images without border artifacts. It eliminates the need for overlapping denoising predictions, significantly reducing the computational complexity of the denoising process. Furthermore, SpotDiffusion can serve as a drop-in replacement for existing diffusion models that previously relied on multi-diffusion, making it a practical and efficient solution for high-resolution image generation.
So SpotDiffusion offers a significant improvement in terms of efficiency and quality for generating high-resolution panoramas. What are the potential applications of this method?
SpotDiffusion has potential applications in various fields, including computer vision, graphics, and virtual reality. It can be used to generate realistic and immersive panoramic images for applications such as virtual tours, 3D modeling, and video games.
That's exciting. Can you elaborate on the potential impact of spot diffusion on the field of image generation?
SpotDiffusion has the potential to significantly advance the state of the art in high-resolution image generation. By offering a more efficient and practical solution for generating panoramas, it opens up new possibilities for creating realistic and immersive visual experiences.
It's clear that spot diffusion is a valuable contribution to the field of image generation. Are there any ethical considerations or potential risks associated with this technology?
As with any powerful generative model, spot diffusion can be misused to create deepfakes, infringe on copyrights, and produce biased images. It's important to develop safeguards and ethical guidelines to mitigate these risks. This includes promoting responsible use, developing deepfake detection methods, and protecting intellectual property.
Thank you for this insightful discussion on spot diffusion. It's clear that this method has the potential to significantly impact the field of image generation, but it's crucial to address the ethical considerations and potential risks associated with this technology.